Good everyone, you are welcome to class. If today is your first time of joining this great family of scholars, you are wholeheartedly welcome. And for my returning subscribers, thank you for always coming back. What we do on this platform is that I teach mathematics and physics. But for today, I'll be teaching a topic in mathematics. Without much ado, let's jump right into what we have for today. But before we start, as I will always say, what you don't know is more than you. As a result, stay put, watch this video to the end so that you can know what you never knew before. For today, we'll be looking at the part 1 in the number-based system series, which happens to be the number-based system. The number-based system is a system of counting which involves numbers in different bases. Number bases include base 1, base 2, base 3, base 4, base 10, base 11, and so on and so forth. These number bases are used in counting. Counting which involves addition, subtraction, division, and multiplication. But in our everyday life, the number base that is used in counting, the number base that is used in transacting business that involves money is the base 10. This base 10 is also called the binary system or the decimal system. The digits used in base 10 are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These 10 digits are the digits used in base 10 or in binary system or in decimal system. Now take a look at this number. 6203.721. If you want to call this number, you say in words, you say 6203.721. Why is it called like that? It is called like that because it is in base 10. How do we know that it's in base 10? Now look up. Let me write the number again. Now let me write the number in the place value using the place value diagram. Something like this. We have 6, we have 2, we have 0, we have 3, we have our point here, we have 7, we have 2, and we have 1. Now, the value of 2 here, the value of 6 here is 1000. And 1000 can also be written as 10 raised to the power of what? 3. The value of 2 here is 100. And 100 can also be written as 10 raised to the power of 2. The value of 0 here is tens. And tens can also be written as 10 raised to the power of 1. The value of 3 here is units, and units can also be written as 10 raised to the power of 0. The value of 7 here is tenths, and tenths can also be written as 10 raised to the power of minus 1. The value of 2 here is hundredths, and hundredths can also be written as 10 raised to the power of minus 2. The value of 1 here is thousandths, and thousandths can also be written as 10 raised to the power of minus 3. If you observe, in mathematics, a number that is raised to a power is known as what? A base. So if you observe now, all of them here are 10, 10, 10, 10. All these are what? Base 10. So it is because of this that we know that it is because of this base 10. That's why we call this number 6,203.721 because the number is in base 10. We can write the expanded form of this by saying 6 multiplied by 10 raised to the power of 3 plus 2 multiplied by 10 raised to the power of 2 plus 0 multiplied by 10 raised to the power of 1 plus 3 times 10 raised to the power of 0 plus 7 times 10 raised to the power of minus 1 plus 2 times 10 raised to the power of minus 2. And the last one, you can write it here or there, anyone. Let me write it here. Plus 1 times 10 raised to the power of minus 3. So with this, you know that this number is in what? Base 10. So apart from base 10, we also have other bases like base 2, and that base 2 is also called binary system. We also have base 3, base 4, base 5, base 6, base 8, base 12, base 16, and so on and so forth. Now, let's look at how we can write what we just wrote in base 10. Let's see how we can write it in base 2. For base 2, if you are given a number like this, let's say 1, 0, 1, 1.101 in base 2. So, if you want to write it the way we have done that of base 10, you just have to what? Take the first number. Take the first number, 1. Oh, sorry. Take the first number 1, and that 1 will be base 2. We are taking base 2. 2 raised to the power of 3. Then this second one, 0, will be what? 2 raised to the power of 2. This one will be what? 1. This one will be 1. 2 raised to the power of 1. And this other one will be 1. 2 raised to the power of 0. Point. This one will be 1. 2 raised to the power of minus 1. This 0 will be 0. 2 raised to the power of minus 2. And this one will be 1. 2 raised to the power of minus 3. So in the expanded form, this becomes 1 times 2 raised to the power of 3. With this 2, 2, 2, 2, 2, it shows that what? This is what? Base 2. Shows that this number is in what? Base 2. You can call this 2, 2, 2. So plus 2 times, plus 0 times 2 raised to the power of 2, open a bracket, close the bracket, plus 1 times 2 raised to the power 1, plus another 1 times 2 raised to the power 0, plus the 1 after the decimal, 1 times 2 raised to the power minus 1, plus this 0 times 2 raised to the power minus 2, plus this last one, 1 times 2 raised to the power minus 3. So just the way we have done for base 10 and base 2, other bases also follow the same pattern. So had it been this number is in base 3, we'll put in 3 here, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, and so on and so forth, just like that. If you observe something, okay, now I forgot to tell you this. The digits used for base 2, or you call it the binary system, are just two digits, 0 and 1. Now what do you observe? For base 10, it was 0 to 9. For base 2, it was 0 and 1. Now what do you observe? You observe that for base 10, the greatest or the highest number here is 9, which is 1 lesser than what? The base number, which is 10. Then if you come to base 2, which is the binary system, we have what? 2 digits here. And the greatest number here is 1, which is what? 1 less than what? The base number 2. So what does that tell you in general? It tells you in general that the greatest number in any number base is 1 less than the base number. That means the highest number of digits of a number in base 10 will be 9, which is 1 less than what? The base number, which is what? 10. Also, the highest number of digits in base 2 will be what? 1, which is what? 1 less than the base number, which is what? 2. So also the highest number in base 3 will be 2, which is what? 1 less than what? The base number 3. So if you have a number given in a particular base, the highest digit in that number should not be equal or greater than the base number of that number. Now what do I mean? Look up. If you write, if you say 6, 3, 4, 2, we now say this is in base, let's say base 5. This I write the base 5. This number cannot be in base 5. Why? Because the highest digit here is 6, and this digit is greater than the base number 5. So this number cannot be in base 5. Now look at this number that is in base 10. You see that the highest digit here is what? 6. So it's far less than what? The base number, which is what? 10. Look at this one. To look at this number, which is in base 2. If you see that the highest digit here is what? 1. Which is what? 1 less than what? The base number of, which is what? 2. So also, if you have something like this, let's say 6, 3, 4, 2. We can say this number is in base 7. It will be correct. You can say it's in base 8 to be correct. You can say it's in base 9 to be correct. You can say it's in base 10 to be correct. Why? Because the highest digit here is lesser than the base number, which is what? 7. Also, if you can also say this number is in base 8, as far as the highest digit here is lesser than base 8. So that's what we mean when we say, in general, the greatest digit in any number base is 1 lesser than the base number. Now, we have done that of the binary system, which is base 2. Now, base 2 or binary system is used in computers. Now, because the binary system have just 2 digits, 0 and 1, it is used in what? Computers. In computers, the 0 there means to off the computer, while the 1 there means to on the computer. That's why the binary system is used in computers, or any other word, machine. Now, octal system. Now, why we selected these ones out is that these ones have specific names. Why we selected these base numbers out is because these base numbers have specific names. Like this, what? Ternary system, that's base 10. Binary system, that's base 2. Octal system, that's base 8. Duodecimal system, that's base 12. Hexadecimal system, that's base 16. We also have other base number, base 3, base 4, base 5, and so on and so forth. Those ones don't have specific names like this. So that's why, because this one has specific names, that's why I selected these ones out. Now, also, octal system, that's base 8. If you observe, look at the digits used in octal system, that's base 8. 0, 1 to what? 7. So you see that the highest digit here is 1 less than the base number, which is what? Base 8, which is also called octal system. Then while for the duodecimal system, which is the base 12, the digits used are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 10 cannot be written here, because 10 is 2 digits. So you cannot see 10 as 1 digit. So instead, we have to replace 10 with what? A. If you see A here now, A is just a single number, a single alphabet. So it's assumed that it's a single digit. So in place of 10, we have A, and in place of 11, we have B. So 11, which is B now, is what? The highest digits in what? The base 12, in the base 12, or in the duodecimal system. So, and that 11 now is 1 less than what? The base number, which is what? 12. Then right for the hexadecimal system, which is what? Base 16. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then when it gets to 10, 10 will be replaced with what? A, 11, B, 13, 12, C, 13, D, 14, E, and 15, F. So that 15 now is what? Is the highest digit on that word, base 16. And that digit now is 1 less than the base number, which is what? 16. Now take down this assignment. Number 1, write out the digits in base 17. Number 2, write out the digits in base 5. Number 3, can we say 2436 is in base 5? If your answer is yes, write it in the comment section and give your reasons. If your answer is no, write it in the comment section and also give your reasons. If this video has been helpful, please give it a thumbs up, like, share to as many people that want it. Comment. Your comment is very, very important to us. Comment whether this video was nice. Comment if there's something you feel I can do better that I did not do in this video, so that in the subsequent videos I will improve on it. Above all, subscribe and follow me if you have not yet done that. And as you do so, may God bless you richly. One love.